I'm just going to give a quick spiel about PNSQC, and then we'll get into the talk for today. So I'm going to go back to sharing my screen. As you know, Bas is here. We're going to be talking with him. He's going to be talking with us about lots of information. And his personal mission is, I took this from his LinkedIn page, helping teams take their first or their next step in test automation. So I'm sure you'll talk about that a little bit. But first, we'll talk about PNSQC. PNSQC is the oldest software quality conference in North America. And let's see if I can remove my spotlight. Hold on. Remove spotlight. There we go. It's the It's the oldest software quality conference in North America, and also we don't have any evidence to the contrary, so we're going to say it's the oldest in the world too. It's held every year in Portland, Oregon. We're all volunteers, and we're a nonprofit organization. I think this year we're also trying to take advantage of the 501c3 status to do some fundraising. So go to our website, pnsqc.org, to check that out. The thing that makes PNSQC different than a lot of the testing conferences and or developer conferences is that we focus on the quality practitioner. So we're looking at hands-on pragmatic solutions to software quality, and it's not just testing, it's not just how to develop things better, but it's a synergy of the two things. So we have a range of topics, and actually this year we have a large number of things about AI, machine language, and how to use that, and surprisingly, some thoughts about better ways or warnings about ways not to use AI and machine language. This year, we have a couple of initiatives. We want to create community and connections with the common passion of software quality. So that's why we're doing our meetups this way. We're having both in-person and online meetups, doing this every other month. And that way we can meet people in person, but then when we can also reach up across the globe and bring people in, like Bas, who's in Holland right now. And, so some of the other initiatives that we're doing is we want to reach out and get more volunteers involved with the organization, because we are an all volunteer organization, and we want to try to offer more than just the annual conference. And so we've been doing the monthly meetups. We've been trying some other things, like we had an open space event in March, I believe, and we're also we have given away a couple trainings for people through a lottery. And we just want to also we've been working on reaching out to our community and expanding diversity in multiple dimensions. So lots of things going on there. One thing I wanted to point out is this year's conference in October will have some great workshops. And time and again, people have said that the workshops at PNSQC are a great value. So if you're interested in any of these topics, you should really check them out. You can see Bas is there in the afternoon solving the integration testing puzzle with contract testing. I wanted to point out a bunch of other things, but I don't have time for that. Michael Bolton will be doing a full day session of his rapid software test automation class. Rachel and Carl Kibler are doing an AI testing workshop. We also have Tariq will be doing a similar class, but different, prompt engineering. We have a lot of things. Jason will be also doing something with AI. Lots of things to look at. And also for the newer people into testing, Heather Wilcox is putting together the new Tester's Handbook. So these are all really interesting classes. If you wanted to send your colleagues to Portland, if you haven't been to Portland recently, it's a great thing to check out. And also, I see Michael Larson's here on the call today. He is our volunteer marketing person, and he's put together these t-shirts. So I just thought I'd shout him out. It looks good. If you come to the conference, or if you even see Michael or myself in person, we'll give you one of these t-shirts when we have them in hand. And again, I wanted to just mention, we need all sorts of volunteers. PNSQC is volunteer-based, and so that means that it's really your conference and your organization if you become involved as a volunteer. And just wanted to thank you also to all the people that are helping out. Right now, a lot of the technical paper authors are really working hard to finish up their papers for the conference, and each paper has been reviewed by at least 2 people as a peer review. So that's really a lot of people to put that all together. And then we'll put that together into the proceedings that will be published and available after the conference. So those are some things to think about. All right, I'm going to stop my sharing. And now we'll go back to Jeremy, and Jeremy's going to introduce Bas.
All right, so here we have today Bas Dijkstra, as you all know. He's been in the automation field for 17, 18 years now, and he has been a speaker for hundreds of different talks, written hundreds of different blog posts about his experience with test automation and all things QA. He is also the developer of restassured.net, which is a library that's essentially takes REST Assured that's written for Java and brings it to C#. And today he's going to be talking a little bit about API security and how to test for security in your APIs and using the top 10 OWASP API guidelines as examples of things that we should be looking out for. So, Bas, go ahead and take it away.
Thank you so much for that introduction, Jeremy. And to you too, Moss, of course. Can you quickly confirm, Jeremy, that you can see my screen now?
Yes.
Welcome to the world's ugliest slide deck. There's actually a little bit of an idea behind this. This is what the monitor of my very first PC looked like. I think at least some of you can relate to this. So it looks vaguely familiar to some of you. And also I've been told it's quite easy on the eyes. So that's why. So yeah, thank you. And thank you, of course, to everybody who joined us for taking the time out of your day. And though, at least for one of you, it's just as late as it is for me. So, hi, John. So thank you all for joining us. I wanted to talk to you today about, as Jeremy already said, about API security testing. And why do I talk? It's a relatively new topic to. Of course, API security testing is not new. APIs aren't new, but especially over the last couple of years, I've seen more and more people talk about API security testing, dive into API security testing. And I've summarized a couple of key reasons, or well, I stole a picture that summarized some of the key reasons here. Gartner said in 2022 that APIs are now the most frequent attack vector. So it's one of the easiest entry points for people with malicious intent to try and do funny stuff with your computer systems. Combine that with the fact that, and again, these are numbers from 2022 and I have no reason to believe that that number has gone down. 83% of all the internet traffic is API driven and was in 2022. So that's a lot of data. And of course, there's lots of people who are interested in that data. And not all of those people should have access to that data. That also means that there's high profile breaches at least on a weekly basis, and I think it's more on a daily basis these days. And of course, there's lots of rules and regulations and laws that people and companies have to comply to when it comes to keeping the data of their customers, their users, clients, their citizens safe. So all of these things make API security testing a very popular topic. Now, typically, and this is a view that I shared until pretty recently, I thought, well, security testing, that's something left to the experts. The people that I know that work in security testing do just security testing. It's not something that you do on the side. And that makes sense because it is a broad topic. Security is a very broad topic. And just keeping up to date with all of the latest and most recent developments in security, that's a full-time job. So until recently, I thought security testing in general and API security testing specifically, that's something for I leave that to the experts. But it turns out I started reading a little bit more about it, seeing other people talk about it. And I learned that there's a lot of things you can do just using common API testing tools and a healthy dose of curiosity and creativity. And again, we as testers, that's what we do. We are curious. We are creative. We are, we like to explore. We like to find out more about quality, about risks, about, is there some kind of problem here? And it turns out with API security, of course, if you want to dive really deeply into all the nooks and crannies when it comes to API security, that'll take certain expertise, certain skills. But there's a lot you can do with basic tools like Postman or REST Assured or SOAP UI or whatever, and common sense. And a base, of course, it helps to have a basic understanding of what APIs do. And that's why I developed this talk and a workshop and demo. So I find myself talking about this topic fairly recently, and it resonates with a lot of people and with a lot of companies. So what I'm going to do today is I'm going to talk you through a number of common API security vulnerabilities, and I'm going to show you some very straightforward experiments that everybody can do, again, just with common basic API testing tools. So you don't need specialized tools. You don't need a lot of specialized security testing knowledge. And yet there's a lot of very valuable information you can find out about the security of your APIs. So I could talk about that until I'm blue in the face, but I like to actually show stuff. So let's do just that. Let's start with demo 0. And of course 0, because we're engineers. We start counting at 0. So this is an endpoint that creates students in a student administration system. So I've got a first name John, last name Smith, and a major, and he majors in computer science. If I send this, that's all good. It's accepted. New resource is created with ID 123. It could probably, if I wanted to make sure that the data is actually stored safely, I could retrieve the data again using an HTTP GET. But I'm not really interested about it. Those are tests that you can do, that are valuable to do, that you probably do already. But we're talking about security here. And the first question I typically get from a lot of people is, oh yeah, I want to dive deeper into API security testing as well, but where the bleep do I start? One of the first things I like to do is to find out how my API deals with potentially insecure inputs. That can be request body elements. That can be request header values. It can be query parameters, path parameters, all kinds of, basically any way an API accepts data. So, for example, what happens if we change this input, oops, there we go, to this. So this is a very benign little JavaScript snippet, so it just shows an alert. What I want to know is, does my API properly sanitize this? Does my API reject this as input? Why do I want my API to reject this as input? Because if this little JavaScript snippet is just stored into a database, and then that data is retrieved by someone using a graphical user interface through their browser, there's a high chance that this piece of JavaScript is actually going to be executed in my browser, which means that all kinds of funny stuff can happen. And again, this will just show an alert, but I could replace this with a little snippet of JavaScript that does things like harvesting cookie values, session IDs, other kinds of login authorization data, credit card information, bank account numbers, whatever. So I want to make sure that it's impossible to inject this kind of data into a system through an API. So in this case, this is not good. This is not what we want to see. I don't want to see this created and then my API just return this return the same value. I want to see in kind of an error message that says, I don't like this kind of input. I rejected this input. So this is a very simple, very straightforward example, but this already tells me a lot about the amount of time and attention that the people who develop this API spend securing that API. Because if they didn't do this, there's probably a lot of other things that they also didn't do. So this is typically my starting point when I start looking at API security. How does my API deal with potentially malicious input? That can be a little snippet of JavaScript. This can be SQL injection. So if I just add drop table customer to the end of some kind of value, and that's stored into a database and executed by some kind of stored procedure, it might just drop all the data, which is also probably something I don't want. So, and there's different flavors of malicious input that I could try. There's all kinds of interesting. So if I Google for the big list of naughty, so that's the right spelling. For the big list of naughty strings, there's lots of, where is it? There we go. Oh, this is all base 64 encoded. So if I would decode this, there's all kinds of interesting values that I could try out and see how my API deals with this. Because again, this tells me a lot about how careful my API is with the data that I submit to it. If an API doesn't properly deal with this, we say that this API is vulnerable to injection. And injection is number 3 on the most recent OWASP security top 10. Again, this applies to JavaScript injection, SQL injection, other kinds of injection as well. Basically, any kind of malicious input that you can inject into a system, in this case, through an API. And just to show that it's a real problem, this is what happened at eBay a number of years ago. They had a pretty severe cross-site scripting, which is very, very similar, if not the same as JavaScript injection. They use the URL parameter somewhere, but the value wasn't checked or validated or sanitized, which means that hackers could inject data into the eBay systems and use that to harvest eBay seller account data, gain access to that data, and do all kinds of interesting but highly illegal stuff on eBay just by gaining access through that simple URL parameter. So you might have heard about the OWASP Security Top 10 or about OWASP in general. For a number of years, they've maintained an API-specific vulnerability list as well. That's called the OWASP API Security Top 10. So there's the initial version was published in 2019, and the most recent one is 2023, so last year. And in the remainder of this talk and the remainder of the time that we've got together, I want to show you a couple of vulnerabilities that are specific to APIs, how to test for them, and just tell you a little bit more about how to find them and what they actually look like. So let's have a look at another example. That's this one. There we go. Let's say I'm a user of an online banking platform and I'm Susie. I'm authenticating as Susie, at least. That doesn't say I actually am Susie, but let's say I'm authenticating as Susie. And Susie has a bank account with ID 543 at this bank. So what that data is retrieved, it shows me that, yes, this is bank account number 543, and that's Susie's bank account, and they have a pretty healthy balance. So that doesn't look too bad. Now, if Susie had malicious intent, I'm not saying she does, but who knows, or maybe someone is impersonating themselves as Susie, they could run a very simple experiment to say, well, if this is what account numbers look like, let's just try a range of these things. So let me try and don't just try and retrieve data for account number 543, but maybe I also, let's see what happens if I return data for 542. So in this case, it's getting slow. This returns a 404, which is actually what I expected. So this gives me the least amount of information while still returning something useful. This tells me, as a potential, this tells me nothing. This tells me that another typical HTTP response status code that you see in this situation is a 401, unauthorized. But that tells me, as someone with malicious intent, as a hacker, that account does exist. You just don't have access. You're not authorized to see it. Which says, let's see if there's a way around that authorization and then get that data. A 404 means either the account doesn't exist or the account does exist, but we're not going to tell you that it exists. So this is actually the safer option and a security good practice to return a 404 in this case. But let's see if that's true for a wide range of bank account numbers. So let me run that collection, then only this one, and select a data source that I prepared here with account numbers. So I'm doing the exact same thing, but now for accounts 500 through 599. I've added a little test here that says I'm going to verify that the status code is equal to 404. There's a range of 100 accounts. I expect one of them to fail. That's because there's one account that I am allowed to see, account number 543. So that returns a 200, which makes this test fail. So I'm going to run this test. It's going to iterate over all the account numbers in the list. So all of them pass. This is 543. So we're good. Oh, this doesn't look good. It tells me that 98 out of the 100 account numbers returned a 404, but there's 2 that returned something else. Actually, there's 2 that returned a 200. 543, we expected that. But there's also number 572. And indeed, when I try and retrieve that, it tells me, oh, it's getting slower. This happens when I start sharing my screen. It tells me, oh, but this is Andrew's account. This is not Susie's account. So even though I authenticate as Susie, I'm able to see data that's associated with Andrew. And now let's assume that Andrew and Susie aren't married. Susie's not a joint account holder on this account, but still she or the person who impersonates themselves as Susie has access to data that they shouldn't be allowed to see based on who they are or who they say they are. That's an example of, in OWASP API security terminology, broken object level authorization. So I'm able to see data that I shouldn't be able to see based on who I say I am. And it's actually, it's not just on the list, it's the number 1 of the list. So it's the most common API security vulnerability in 2023. And as you can see, it is pretty straightforward to see it, or to see it, to test for it, to run testing, to run tests, to perform testing experiments, to see if there's data that I can see that I shouldn't be allowed to see. Some of the things that help me, that give me hints in the right direction, is these resource IDs. So in this case, the account IDs, they are predictable. It's a if I see a resource with an ID 543, there's a pretty good chance there's also a resource, an account with ID 542 and 544, which is probably just an auto-incremented value. So if you see predictable, these experiments are really easy to perform. If there's a way to find a list of resources, maybe there's a different endpoint that exposes a list of all these resources. Maybe there's an endpoint that returns the entire list of account numbers, and you can use that as input for this experiment again. This is why you see APIs use UUIDs as resource IDs so often. They're not perfect, but at least it's much, much harder or much, much less likely that you'll find an ID that matches a resource that's actually existing. It's just a numbers game. It's all statistics, really. So if you see these predictable, findable resource IDs, you can run an experiment like this and also maybe question the people who designed the app and say, well, are you really sure that this is a good ID? And the more public facing your API is, the more relevant this question becomes, of course. By the way, Jeremy, I see that Zoom shows that there's a couple of messages coming along in the chat.
Those are notes that I'm making of what
Okay,
you're
gotcha.
saying.
Good.
We
If
can
there are
let you
any
know if someone asks a question.
Yeah, or just I'm Dutch. I'm very used to being interrupted, so that's what we do. So if there's any questions, by all means, just speak up, or put it in the chat. So
I have one quick question since you paused. Which version of Postman are you using? Is it in the browser or is it downloaded
this is
desktop?
the desktop one, but it doesn't really matter.
Okay.
So, and it auto updates. So, but this is the desktop version. But the tool that I'm using isn't really, you can do this, maybe the setup, the syntax is a little bit different. I could do this with REST Assured, or I could do this in code. I could do this with Bruno, with SOAP UI, with whatever. Just pick a tool that you're familiar with and that you're comfortable with. You can run these tests with basically any API client. Another thing to watch out for is a lack or insufficient rate limiting or a lack of rate limiting. So rate limiting is a restriction on the number of times a certain machine or a certain user can access a certain endpoint within a given time frame. Why do you want to limit that? Because it makes it harder for people with malicious intent to perform experiments like this, to start looking for data. Again, like with any security measure, there's no one security measure that is guaranteed to make your API or your system in general safe. But if you add enough of them, the likelihood that someone goes through all of these security measures and finds a breach in your API becomes small. Just a slight tangent. I don't know if you are familiar, not with Swiss Airlines, with the Swiss cheese model. If I show you this picture, you get the point, really, I think. So any security measure that you take is a slice of Swiss cheese. It has holes in it, but the more you put into place, the less likely it is that something goes through all of them. A lack of rate limiting in itself is also featured on the OWASP API Security Top 10, at number 4, actually. It's called unrestricted resource consumption, which is OWASP speak for insufficient or a total lack of rate limiting. I can make an unrestricted amount of calls to a certain endpoint. That's also, as you see, and you probably get why, that's also a security vulnerability, a cause for potential security problems, because it makes it easier for people with malicious intent to try and find holes in your security holes in your system, and in this case, in your API. Some examples of what happens if you don't take care of this. This is an example of someone who had access to Bitcoins or could perform transactions with Bitcoins that they didn't own, which I'm not really into the Bitcoin crypto kind of thing, but I don't think that that's a good thing. And this is maybe a bit closer to home for some of you. The US Postal Service had quite a severe problem with this, because any registered user on their website could see all the account details for all the other users, and there's about 60 million of them. So they could see account details, and in some cases they could even modify them, which is another security vulnerability, by the way. So let's look a bit into that. So we've seen BOLA, broken object level authorization, which is about seeing data that you shouldn't be allowed to see, that you aren't authorized to see. But how about altering data? How about modifying that data? So let's pick another request. So I don't need this one right now. This is a system that administers fines, and look, there's a fine that's issued to Max Verstappen for exceeding the speed limit for the amount of 180. Now I'm sure Max Verstappen, this is chump change for him, but most people don't like to pay fines. They don't like to receive fines. They definitely don't. So instead of paying the fine, let's see if there's a way around it. Let's see if we can, in this case, we should be able to see that there's probably some kind of portal that we can log into and say, give me all the outstanding fines. So this is a totally legitimate use of the API. What we probably don't want to be able to do is just delete it, just make it go away. And luckily for us, the API doesn't allow it. It says method not allowed. So you are not allowed to delete this fine. But there are other ways to modify data. So let's try to patch it and say, well, let's try and update the amount from 180 to 0. Oh. And the API accepts it. Or it looks like the API has accepted it. So let's see what has happened now. My fine is gone. So just by patching that resource, updating the amount from 180 and setting it to 0, made my fine completely disappear. Of course, this is also probably not the way the developer of the API intended the API to be used, because, well, people can take advantage of this in ways that they probably didn't predict and definitely didn't intend to. This is called broken function level authorization. So the ability to perform actions on data that you shouldn't be able to perform, that you shouldn't be allowed to perform. And that's number 5 on the OWASP API Security list of 2023. Another way in which broken function level authorization can manifest itself is giving access to admin endpoints by regular users. So allowing regular users to perform admin operations through some kind of special dedicated admin endpoint. That's another way in which broken function level authorization can show itself. Those two related might not be the best way to describe it, but they are definitely often seen together. Broken object level authorization and broken function level authorization. Why? Because both of them depend on proper implementation, or in this case of improper implementation, of your role-based access control. So if you see data that you shouldn't be allowed to see, it's probably that tells you, ooh, someone didn't take enough care of the role-based access control. Let's see if there's something else that we can do with that data. If you see broken function level authorization, you're almost always also encountering this vulnerability. So they often go hand in hand. So again, BOLA, or broken object level authorization, is about accessing data. Broken function level authorization is about the ability to alter or modify data. And they go hand in hand. So if you see the one, it's probably a good idea to look for the other as well. Another example. So when do you want to wrap up the talk and go for questions, Jeremy? I think we have some time left, but
you keep going. You have plenty of time.
Okay, gotcha. Another example. Let's go to this one. This is the API that exposes the backend of a game store to the website. And orders are placed through this endpoint. So maybe someone wants to order a copy of FIFA 24. Sounds good. Accepted. ID, order ID 9342. Looks like it's good to go. FIFA 24 is not a very sought after, highly limited item. So this game shop will probably have plenty of copies of FIFA 24 in store. So people, if they want to, they could order 10 copies in one go. And the game shop, the backend, will accept that. And that's totally fine. If someone wants to order 10 copies of FIFA 24 in one go, I have no idea what you're going to do with them, but if they want to order 10 copies of FIFA 24 in one go, in one order, be my guest. However, there might also be items in stock that are strictly one copy per person only. A limited edition item, and you want to make sure that every one of your customers only orders a single copy. So this is okay. By the way, Gamma Attack is what Google showed me when I did a search for the world's rarest, most exclusive video game. Turns out there's only one copy in existence, and it's stored in the safe of some way too rich person somewhere in the United States, actually, I believe. And I think nobody has seen it for 30 years, but I just need an example. And if you want to order 10 copies as a customer, the API says, nope, not gonna happen. Bad request, bad client. I cannot, you can only order one copy of Gamma Attack. So sounds good. And many a developer or designer might say, well, okay, this is good. There's no way to abuse this. There's no way for any customer to order more than one client, because if the order quantity is more than one, the API is just going to reject it. The problem is, though, if I order 2, 3, 4, and so on copies, what the people who designed and developed the API forgot to cover is the case where a single customer ordered multiple copies of this in consecutive orders. And this is an example of unrestricted access to sensitive business flows. I think this is the vulnerability on the list with the longest name, by the way. So sometimes people say UASBF, but well, that's not really helpful. Unrestricted access to sensitive business flows. This is not about your data necessarily being at risk of being exposed, but it's about allowing people to manipulate or use business processes, business flows, or circumvent business rules through APIs, or to use business processes, or to avoid restrictions, those kinds of things, through your API. That's what unrestricted access to sensitive business flows is about. And as you can see, it's number 6 on the list. So it's fairly common. It's a fairly common phenomenon as well. But how do you prevent those? This is especially where I think we come in as testers. So some of these things that we've seen before, anybody could do that. You could even write tools or scripts that automate that stuff. This is where people who excel at critical thinking come into play, because if we want to make sure that nobody can make illegal or unlawful or just unintended use of our business processes and our business flows, we need to first identify these business flows and the way people can use and go through these business flows, and then take proper prevention measures, which means you probably need someone who's good at critical thinking, who's good at systems analysis, who's basically good at asking the what if question, testers, to have a good think about, how would people be able to use this? How could people abuse our system if we design it in this way? And once you've identified those ways that people can abuse and misuse these business flows, you can take prevention measures such as device fingerprinting, detecting whether or not someone is a human. Because I think, for example, if concert tickets go on sale, scalpers love to write scripts that quickly buy up all of the available tickets and then resell them at a much higher price. So ways to avoid that are using CAPTCHAs, or other kinds of biometric solutions to see if we're dealing with a human, analyze for and block non-human patterns. So if an add to cart and a checkout operation are performed within milliseconds of it's pretty sure you're a bot and not a human being. Or block IP addresses of machines or networks or bot networks that are known to be used for this kind of illegal activity. So that's an example. These are some of the things that you can do to prevent number 6 on the list, unrestricted access to sensitive business flows. As a final example,
Actually,
now,
before you do that example,
yeah.
I'm just going to quickly interrupt you and let if anyone has questions for
Yes,
for
please.
Bas, yeah, before we reach the top of the hour.
Sounds good. Thank you, Jeremy.
Feel free to speak up or write in the chat, whichever's most comfortable.
Absolutely.
I did have one question. You've shown Postman, but you also talked about REST Assured or Bruno or SOAP UI. Out of those, is SOAP UI are any of them? Are they all equivalent, or is there one that you prefer? Or
it depends. The reason I'm using Postman is because I'm comfortable with it for exploratory. So I'm using tools and I'm using scripts on the, but this is very much the kind of API security testing that I'm doing here is very much exploratory in nature. I'm going to try this. Let's see what happens. I find Postman to be a very good tool for that. Same applies to Bruno, by the way, and SOAP UI. So basically tools with a graphical user interface of its own, because it's just easy to construct the request that I want without having to write code and a framework that actually runs it. I could, if you prefer to work with things in with the library in code, like REST Assured or requests or whatever, to do this kind of thing, because, well, if you stumble onto something, it's very easy to then say, well, ooh, this is something interesting that I saw. Let's make sure it never happens again by turning it into an automated test that I can put on a version control and add to my pipeline very easily. That's another way to look at it. It's just one to pick what you're comfortable with. It's in the end, it's all just tools that help you, well, construct API requests and observe API responses, and for these kinds of things, and especially because I'm demoing stuff here, I'm showing here. a tool with a graphical user interface is much more convenient than doing it in code. But I could have done all the things that I've shown so far in code instead of with a tool with a graphical user interface.
I guess that was, I also had in the back of my mind a secondary question. Like in Postman, all those scenarios, is it easy to save those or export them and put something into Git so that other people can use that in your organization? I don't know.
So that's, yes, you can. So with Postman, you can share collections through the Postman cloud. If you want to store them in your local version control, you can export them, but that gets ugly pretty quickly because
There is
it
a
exports.
way, sorry, I didn't mean to interrupt, but
No, please do.
I'm pretty familiar with this because I wanted to do it with my own project. There is a way to essentially keep it in sync. You can link a GitHub repository to Postman, but it's just keeping a file basically
Yeah.
up to date. It's you can't like directly make commits or things like that. It's just
No.
sort of like keeping the collection in sync. It's not the most robust integration with Git.
No, and that's one of the reasons that Bruno is becoming more popular these days, because um, instead in Postman your entire collection is just one JSON file. With Bruno, it's all plain text, and it's just more version control friendly. And also, Bruno's completely offline. So with Postman, you sync everything to the Postman cloud, which not everybody is a big fan of, and Bruno doesn't do that. That's has nothing to do with one or the other of them being a better client or a better tool for this kind of testing. But if you pick a tool to these kinds of things, and these are concerns that your team or your organization has and has to deal with because of security and compliance and whatever, it is good to keep in mind. Absolutely.
Yeah.
So this is just a really long way of saying it depends.
Yeah, a lot of things to, yeah. Hari asked a question in the chat. He says, systems need, or in quotes, systems need to be secure by design. It's usually an argument and I always get the question, why do we need security testing? How can I reply to this?
Um, because someone needs to implement that design, and you can take all the, but how do you absolutely know that if you, sure, security by design, if you design with security in mind, that's going to help. Absolutely. But is it a guarantee that everybody follows that design? Everybody does things as they should be done? I, for one, if I was dealing with a system that stores and handles sensitive data or exposes sensitive business flows, I would want to make sure that it's not only safe, secure by design, but also secure in practice. So, hopefully, if you design with security in mind, you won't find as many security vulnerabilities. Hopefully, you won't find any at all. But it's no guarantee that everything actually. It's the same as with any specification or requirements in general. You can design them until you're blue in the face, but you won't know for sure if your system actually complies to the requirements, and those can be functional, security, performance, accessibility, any kind of requirement, until you actually build the thing and start using the thing. So that's again why I think it's a very good idea to at least perform some kind of security testing, just like you do some kind. So if I do BDD, I still want, I do all kinds of agreements and discussions about what's the system that we're going to build going to look like and how is it going to behave. But I'm still verifying afterwards if my system actually meets those requirements. And then I'm also going to do some exploration to see if we didn't forget anything. And I don't think it's any different with security.
Yeah, I would agree with that. So to sum up what you said, basically requirements kind of drive all sorts of different kinds of testing, and security testing is just one component of, you know, all the kinds of testing that we should do on
Absolutely. I
yeah.
don't think, and a lot of people, and it's similar to with performance. There's a lot of people see, well, oh, that's something that's left to the experts. I don't want to do this, and that's one of the reasons why I like doing this talk and why I personally think it's important to do this talk, to A, make people more aware that problems like these actually exist, and B, that you can do a lot of things with just, again, I'm starting to repeat myself, with common sense and just basic common API tools, API testing tools. What do you say? How are we doing for time, Jeremy? It's just past the hour.
Well,
I'm good to go on for a bit. I don't know if you want to wrap up.
what do you think, Moss? I think
We
we
could
can
probably
keep
go on
going.
for about 15 more
Yeah.
minutes. I think
Sounds
that's
good.
there. We have people that still on the line and that are
Okay.
interested.
Let's do that. I'm going to do one more example and then I'm going to wrap up. I think that might take me a little less than 15 minutes, but we have some time for maybe a bit of Q&A, and maybe you want to have the closing speech, Moos or Jeremy. Sounds good?
Yes.
So I have another example. And that's this one. So this is another example of two vulnerabilities in one, basically. So I have an endpoint that that changes my that I'm using to invoke to change my password. So I have a password token here, which I need to set my password. Might be some kind of two-factor authentication kind of thing, but so my password needs to meet certain criteria. And you've seen that before. It should be strong, of course. So 8 characters, a digit, lowercase letter, uppercase letter, a symbol, an emoji, a recipe for soup, and I don't know, a picture of your firstborn. I don't know what these requirements these days. No, there should be 8 characters, digit, lowercase, uppercase, and a symbol. So this is, so assuming my old password is this, which is a valid password, this should not be acceptable. And it isn't. That's good. And this yep, this is okay. Now, this is a mock API. It didn't actually change my password. So my password is still this. Jeremy, what do you think? Is this a valid new password?
You're missing the capital.
Huh.
No, that's not good.
No, that's my conclusion as well. So this is broken. There's even though I've got my requirements, so this is an example of broken authentication. So there's a way to circumvent the authentication requirements. So in this case, the password requirements. Fun fact, this is actually what I'm using in the definition of this mock is a regular expression that actually should not match this, but because it's Java, it does, because the Java regex library does some kind of funny stuff. And that's the cause for if you use that if there are actual authentication mechanisms that use this, they would have a security vulnerability. So this is testing for broken authentication. It's okay. Can I circumvent the authentication, the authentication requirements that are set in the requirements for my system? This is not good. However, you might have noticed, so it's pretty secure, this one, or pretty compliant to the requirements, not entirely. But you've probably also seen this v2 here. If I see a v2 in an endpoint, it's probably also a v1 somewhere, which accepts pretty much everything. And that's still usable as well. So my new password is now test. So that's really insecure. I could even use a set blank as a new password. So this is an example of both a broken authentication. So there's a security vulnerability in my authentication mechanism, because even though I've set restrictions to my passwords, there's a way around it. And more importantly, this is an example of improper inventory management as well. This is not really all that high on the list. It's number 9, but it's still something that's very easy. That can cause some very interesting security issues. So if I see a v2 in an API somewhere, the first thing I check is, well, is there also a v1? And that might be that might not be a problem in itself, because, well, maybe the company both supports a v2 and a v1 API, but then I immediately want to know, well, what are the features that are in v1 but no longer in v2? Because that's probably the features that the company doesn't really want anymore. And that might just be for security reasons. So, or it could just be that, well, everybody should use v2, but they just forgot to take v1 offline, or a beta version, or some kind of other kind of version for the API. That's called improper inventory management. That applies to API versions, that applies to specific endpoints that should be decommissioned but can still be accessed even though they're not in the documentation anymore. Because the fact that they're not in the documentation, not in the API specification, doesn't mean they're no longer there, because somebody actually needs to take that stuff offline. Failing to do so is an example of improper inventory management. And, well, again, people can use that kind of stuff for those endpoints, those older API versions, for their own benefit. So that's a lot of potential security. We covered most of the entries in the OWASP API Security Top 10 now. There are a couple that we missed, which is broken object property level authorization. That's about seeing more data than you should be allowed to see. And so even if I see a resource, I might not be allowed to see all the fields or the properties of that resource, and broken object property level authorizations is a violation thereof. I have server-side request forgery, which is if my endpoint accepts fields that are a URL, I can do some, I can inject malicious URLs into a system through that, or do things like port scanning using server-side request forgery. Security misconfiguration is basically an umbrella term for all kinds of other kinds of security flaws. And number 10 is unsafe consumption of APIs, which is the only entry in the list where it's the consumer, so the client, that's the security vulnerability that creates the security vulnerability, and not the server/provider. Unsafe consumption of APIs is about if, as a consumer, I consume data from third-party APIs, I need to make sure that that data is safe. If I don't do that, if I don't do that enough, it might mean that unsafe data enters my system, which is an example of unsafe consumption of APIs. I'm going to skip this example just because of the time, but hopefully through the examples that I gave in the talk and the tests that I run, you've seen that there's a lot you can do when it comes to inspecting, getting information about testing the security of your APIs without very deep, very specific API security expertise. So what we've used is common API testing tools, just curiosity, a little bit of creativity, and the OWASP API Security Top 10 as a guideline to uncover lots of interesting information about the security of our API. If you want to learn more, there's one resource that I can definitely recommend. That's API Security University, API Sec University. Let me close these ones very quickly. It's an online platform. The setup is very, very similar to Test Automation University, which is a platform that most of you are probably familiar with. The only difference is that this, of course, it's all in a name, is mostly dedicated to API security. So there's a number of courses on there. All of the courses are free. There are some certificates that you can gain with exams. Those are paid for, but all of the courses all of the content on that is free. I would particularly recommend the API Security Fundamentals as a starter course, and then the OWASP API Top 10 and Beyond course. Those two give you a good, solid foundation in very common API security problems and how to test for them, and the kind of countermeasures you can take to prevent them too. The other courses on here are either dive deeper into topics or cover specific areas for API security. So PCI compliance, API security in connected cars, for example. There's a specific one on API authentication. All of these courses are free. And there's an upcoming one on LLM and NLP APIs, which is bound to be pretty interesting as well. So that's API Sec University. And with that, are there any additional questions? Jeremy.
Yeah, well, thank you, Bas, for this talk. That was awesome to learn more about all the different security vulnerabilities and how easy it is to essentially test for them without specific security training. So there was one question that came up when you were wrapping up from John, who asks, do you also recommend to automate tests for testing security, with that OWASP list in mind and then do exploratory testing?
Yeah. The short answer is yes. So let me quickly share my screen again because there's one thing that so there are a number of tools that you can use to do this. So Zap, Burp Suite are tools that can help you do this. The people behind API Security University also have a scanner that you can add to your CI pipeline that specifically tests for a number of these OWASP security vulnerabilities. It sounds very promising. I must say I have not tested it. I've not used it myself, but I've seen it recommended in various places. So, and you can try it for free. So that's probably something you want to. I can't tell you anything about the quality of the testing that it does, the quality of the information that you get from it. I really need to check it out, but I need to find the time. But it's at least it's worth checking out because the easier you make it to do these kinds of scans, and the more often you do it, the better the information you'll get about it, the better insights you'll get into the security of your API. So would I leave everything to the tools and to the automation? Probably not. But it's about it. It's like with all things testing and automation, it's about finding the right balance and see what works best for you. Graag gedaan. You're welcome, John.
Anyone else got question before we wrap things up?
Sounds like a no. Then let me just
Moss, you're muted.
So let me just very quickly say before, and I know you're going to wrap up with it, but thank you all for joining, for taking the time out of your day. I really appreciate it. And of course, I hope to see you in October. Over to you. Thank you.
Were you gonna say something, Moss?
No. I was just going to say thank you.
Awesome.
I saw you talking and I wasn't sure. Yeah. Well, if that's it, we can give folks a little bit of time back that they might not have been expecting. But
Yay, more coffee. Not for
yeah.
me, but yay, more coffee.
Well, it's nighttime for you, so
It is, yeah. It's time to wind down. It's 10:15 here, so. But that's okay.
all right. Well,
Thank you
thanks
so much.
everyone for coming. Appreciate it.
Ciao. I'll end this now. Bye.
Cheers. Bye-bye. Thanks.
Bye,
Speak
everyone.
soon.